Hello, this is Mrs. DB, and today we are going to work on probably a review from algebra on how to write lines in the coordinate plane, and this is from Chapter 3, Section 6. So to begin with, you're going to have to remember how to do problems like this. So these warm-up problems would be good for a little quick review. So the first part is you're just going to substitute the values of m, x, and y into the equation y equals mx plus b, which you should recognize as the slope-intercept form of the line, and then solve for b. And then in the second part, just solve for y. So y equals is how we want it. So do these problems. To do number 1, you would put 2 in for m. X is 3, mx, that means times, and y is 0. Whoa. So you'd have 0 equals 6. Sorry, my pen got crazy there. 0 equals 2 times 3 plus b. So that's 0 equals 6 plus b. So you should have got b was negative 6. You'd subtract 6 from both sides. For number 2, you'd do the same thing, and you should have got the b equals 1. In number 3, you should get y equals 6x plus 9. If you wrote y equals 9 plus 6x, that's fine. They write it 6x plus 9 so that it matches the slope-intercept form of a line. And for number 4, you should have got y equals 2x minus 4. So if you got those, you're ready to continue with this lesson. Our objectives today are to graph lines and also to write their equations in slope-intercept and point-slope form, to classify lines as either parallel, intersecting, or coinciding, which means they're exactly the same line, and to determine if given coordinates form a right triangle. We're going to use point-slope form and slope-intercept form today. And in both of them, we'll use m for slope. And if you use b, that is the y-intercept. That's where it crosses the y-axis. You only use that in slope-intercept form. In the other ones, we're going to use x1 and y1. What those are is a coordinate that it will be given to you from your problem. So if they give you a coordinate, I don't know why that's doing that. I swear I did not make that bizarre looking shape. Looks like the back end of a car. Anyway, pretend there's a parentheses there, and you'll use that in point-slope form. All right, so here's point-slope form. You should put these in your notes, or print. This will be in on your worksheet for 3.6. You'll want to make sure you know point-slope form. It's where you have y minus y1 equals m times x minus x1. The colored parts will be replaced with the information that is given to you in the problem or that you find. The y and the x, the black ones, they don't change. They'll stay there forever. That's part of the equation. The slope-intercept form is y equals mx plus b. M is the slope and b is the y-intercept. The blue and the red one there will be replaced, and the y and the x stay there. And then in a vertical line, that's an up and down, straight up and down line, the equation is always x equals whatever number it goes through on the x-axis. So you don't need a slope or anything. It's just y, it's x equals whatever. X equals 5, x equals negative 3, wherever it crosses the x-axis. And a horizontal line is always y equals whatever number it crosses the y-axis at. So y equals 2, y equals 0, y equals negative 7, whatever. But it's just y equals. No, that is the y-intercept. No slope is needed because the slope of a horizontal line is 0. Y-intercept is 0 and then the number, and an x-intercept is the number and then 0. All right, we are going to write the equation of each line in the given form. So first of all, let's write down our forms. Slope-intercept form is y equals mx plus b. Point-slope form is y minus y1 equals m times x minus x1. Slope-intercept and point-slope form. All right, so we want the line with the slope 6, that's m, through a point that is given. That's our x1, y1. And they want it in point-slope form right here. So you're going to write down the point-slope form, the general one. We will replace the slope, the x1, and the y1 with what they tell us those are. So 6 goes in for the m, 3 goes in for the x sub 1, and negative 4 for the y sub 1. So we have minus a negative 4. Whoa, where's the rest of that? Oh, I wouldn't leave it like this. Did they leave it like that? No. I would substitute, I would simplify, I'd change that to y equals, minus a negative is the same as plus 4, and I would change this to then, there's that crazy pen again, x minus 3. Okay, well something is going on with my pen, but that says x minus 3. Okay, write the equation of each line in given form. The line through negative 1, 0 and 1, 2 in slope-intercept form. They're giving us this so that we can find the slope. Remember, the slope formula is y2 minus y1 over x2 minus x1. So they called this one x1, y1, and they called this x2, y2. And the slope formula is y2 minus y, what is going on here? Minus y1 over x2 minus x1. That's the slope formula. So they took 2 minus 0, that's the y2 minus y1, and then 1 minus a negative 1 is the same as 1 plus 1. So they got 2 over 2 is 1. That's the slope. That only gets you the slope. Now they want slope-intercept form, so that's the m in y equals mx plus b. So we would put 1 in for m. Now you get to pick a point for the x and the y in order to try to solve for b. So we don't know what b is. So let's just pick this point. The x of that point is negative 1, and the y is 0. So you put 0 in for y, you put 1 in for m, negative 1 in for x, and you solve this to get what b is equal to. Then you have one more step, and the last step is to rewrite this y equals mx plus b, replacing m and b that we just solved for where they belong. And you don't have to put the 1 in front of the x unless you want to. So you could write this as y equals 1x plus 1, or you can just write y equals x plus 1. Okay, one more example. This one's an easy one. It says write the equation of each line in the given form, the line with the x-intercept 3 and the y-intercept negative 5. So when they give you, I'm not sure why they said use that point. I would write this as 3, 0, and I would write the other one as 0, negative 5. Okay? So I'm going to use those points to find the slope. So m is equal to negative 5 minus 0 over 0 minus 3. So our slope is 5/3. Okay, and then we will use point-slope form. In point-slope form, it's actually easier, even though it's longer to write. You put m in that we just found, 5/3, and then you get to pick an x1, y1. Well, I'll pick the 3, 0 one. So 3 is x and 0 is y. So we would simplify this to be just y equals 5/3 x minus 3. They left it as y minus 0, which is fine as well. Oh no, they simplified that one. So y equals 5/3 times x minus 3. It doesn't look like point slope anymore because it doesn't say y minus something, but it's y minus 0. Okay, this is just some practice for you to do with each of those other ones, so you can pause the video, try these on your own, and make sure you get them right, and then we'll check your answers. All right, this one wants slope-intercept form, and the slope is 0. This is interesting. If the slope is 0, they told you to write it in slope-intercept form, and then they wrote point-slope form. So let's see if this makes sense. They're going to substitute 0 in for m, 4 for x sub 1, and 6 for y sub 1, and they get that. Now they're supposed to be writing this in slope-intercept form, so they can't do that until they actually simplify. 0 times anything is 0, so you don't really have to do the distributive property. And then you would add 6 to both sides, and you get y equals 6. That's in slope-intercept form. That is the equation of a horizontal line going through the y-axis at 6. Okay, try this one. You'll have to find the slope first. So the slope you should have found to be 0. Well, that's interesting. What kind of lines have a slope of 0? Not vertical, those are undefined. Horizontal lines do. If you plug 0 in, you can go through all this work, but it's more work than you need to do. You get y equals 2. Why doesn't that last step show up? And y equals 2, y, add 2 to both sides. That is the y-coordinate of both of these. Y equals 2 is another horizontal line going through the y-axis at 2. Okay, then there's also some graphing of lines in this section. This is written in slope-intercept form already, where the slope is 1/2, 1 over 2, rise is 1, run is 2, and the y-intercept is 1. So the first thing that you do is you put the y-intercept on the graph. So you go up 1 and it goes through the y-axis right there, so you put a point there. Then you do the slope, you apply the slope. That means you go from that point you just graphed, you rise 1 from there, so you go up 1, and then you go over 2 to the right. You always go to the right. And then you make another point, and then you just draw the line that goes through those points and continues on forever in both directions. Now, if it is in point-slope form, you can do it this way, or you can translate it into slope-intercept form if you prefer. To do it this way, you would need to remember that this means y minus y1 equals m times x minus x1, which means then that there is a point that's going through this of the x would be 4, no, it'd be negative 4, and the y1 would be 3. So one point on this graph is negative 4, 3. The slope is just negative 2. That's easy enough to find. So you would graph the point negative 4, 3, and a slope of 2 is the same as the slope of, oh, it's negative 2. So negative 2 is the same as the slope of negative 2 over 1. Always put a 1 underneath. So from here, I would go down 2 and to the right 1. We always go to the right when we do our run. We never go to the left. You go down if it's negative for the rise, and you go up if it's positive. It might be easier to turn this into slope-intercept form, and here's how you would do that. You would first simplify the right side by doing the distributive property. And then we would add the 3 to both sides to solve for y. Now, if I was going to graph that equation, I would start by doing the y-intercept is at negative 5, and I'd put a point there. Then the slope is negative 2 over 1. So from here, I'd go down 2 and to the right 1. So it ending up off of the graph here, but you can see that the point would end up in, or the line would end up being the same line. It's just that it kind of went down below the graph. Instead of going down 2 over 1, you could go up 2 and then to the left, but that's dangerous because I'd like to say always go to the right for the run. All right, let's look at another example. Y equals negative 3. Think about what that means. That means that no matter what x is, y is always negative 3. So it's going to be a horizontal line, straight across, left to right. It's going to go through the y-axis at negative 3. That's it. Those are the easy ones. If it was x equals, let's just do an x equals 1, then it means that no matter what y is, x is always going to be 1. So you would just draw a straight line. All of these points would be on that line, and this would be x equals 1. Okay, so if you have 2 lines being graphed, you could either have the lines could be parallel, the lines could intersect somewhere, or they could be the exact same line. That's what coinciding means. Coincide means the exact same thing. But they might be written in different forms, so you might have to simplify or change one into the other form to be able to tell if that's what they are. If they're parallel lines, this is very important, they will have the same slope but different y-intercepts. So if you write them in slope-intercept form first, that's usually the easiest way of telling whether you have parallel, intersecting, or coinciding. So write them in slope-intercept form first. Write in slope-intercept form. Okay, so we have intersecting lines will have different slopes. It doesn't even matter if the y-intercepts are the same or not. It could be the same, it could be different. The key is that they have different slopes. And if they're coinciding, they have to have the same slope and the same y-intercept when written in the same form and simplified. All right, so let's look at some examples. They're both written in slope-intercept form. That's good. That's our first step is done. We have to see about their slopes and we have to see about their y-intercept. Are their slopes the same? One has 3, one has -3. If they have different slopes, they only have one option. They must be intersecting. That's it. If they have different slopes, they intersect. You don't even have to worry about the y-intercepts. Different slopes, they intersect. Okay, so check the slopes here. Well, if I just glance real quick, I'd say they're different slopes. One has a slope of -1/3, one has a slope of -2. Oh, wait, the second one does not have a slope of -2. We would first need to solve this for y. Okay, there's like a blank spot on my screen here, but I would divide everything by 6. So I would get, here's the work, y equals -1/3 x plus 2. Well, now look at the slopes. Now they're both -1/3. Now I will go ahead and look at the y-intercepts. One has a y-intercept of 2, one has a y-intercept of 5. So they have this, let's look back at our table. They have the same slope, but different y-intercepts, so therefore they are parallel lines. So if they have the same slope but different y-intercepts, they're parallel lines. Okay, one more example. You can't tell this until they're in the same form. So you can either write them both in slope-intercept or point-slope. I would probably put them in slope-intercept form. That means solve for y. So the first one, to solve that for y, you would have to add 4x to both sides and then divide everything by 2. And you get y equals 2x plus 8. The second one, we would do the distributive property and then we would add 10 to both sides. So we've got y equals 2x plus 8 for both of them. So same slope, same y-intercept means you have the exact same line, which is called, they coincide, or coincident, but they coincide. Okay, these are just for you to kind of try on your own and see what happens. So try them and then check your answers. For this one, you should have solved them both for y, and you would find that they have the same exact slope, but different y-intercepts. That means that they are parallel lines. Same slope, different y-intercepts means parallel lines. Okay, one more type of thing that we're going to do today is try to see if we have a right triangle or not, given some coordinates of our points. So the way we're going to do that is we're going to remember that if you have a right triangle, you have one angle that is 90 degrees, one right angle. Well, that's the definition of perpendicular. So it means that we would have two slopes of segments that are perpendicular. And we learned in the last section that perpendicular lines have slopes that are opposite reciprocals, or negative reciprocals. So we don't have to graph these. We could do it without graphing, but let's see what it would look like. So -5, 3, here's A. And you can do this on your own paper if you want when you do your assignment. But you could do it without sketching the triangle. It just kind of helps me see what I have going on. So I want to determine if this is a right triangle or not. Now, I don't have a nice straight line tool in my my toolbox in this program, but I'm going to try to draw oh, that's terrible. I'm trying to draw a straight line there so that I can make my triangle. I was trying to use like a straight edge to do it, but I probably would have been better off just freehanding it. and down here. Yeah. Okay, so that's terrible, but we want to determine if this is a right triangle or not. So in order to do that, and there's something going on with my pen clearly that making it jog right there, but in order to do that, we have to see if there is one right angle. So I'm going to determine the slope of segment AB. So the slope is found by taking y2 minus y1 over x2 minus x1. So that'd be 0 minus a negative 5, which is the same as 0 plus 5. So I would get a slope of negative 5 over 5, which is negative 1. That's this slope, is negative 1. Then I need to find the slope from B to C, the one with the jog in it that's not supposed to be there, and that would be these two together. So 3 minus negative 2 over 5 minus 0. So 3 minus negative 2 is the same as 5 over 5. That's a slope of 1. Now 1 and negative 1 are opposite reciprocals. Let's just find, so it looks like it's going to be a right triangle with this being my right angle. But let's just do the last one. AC would be these two together. So 3 minus 3 is 0. Oh, well that's a horizontal line. So that has a slope of 0. I don't even need to know what the bottom is. But it is a right triangle because angle B is a right angle. Okay, so that's what you do. You don't have to sketch the triangle if you don't want to, but it kind of helps you see if it looks like it might possibly be a right triangle or not. Like in that one, you could probably see that angle B looked like a right triangle. So the next one, if you want to sketch it, you can, but I think I don't have all the way up to 7 on here. Or you can just go ahead and start finding the slopes. And remember that to be perpendicular, the slopes are going to be negative reciprocals of each other. Okay, so that's it for today. Thank you very much, and please come to my office hours or to the ASC room if you have any questions, or send me an email and I will help you out. Thank you very much.